This will be for the con exercise, zeros of polynomials, factored form. So they want us to find the zeros of this polynomial, and basically the zeros of the polynomial are where the polynomial is set to y equals 0. All right, that's why they're called the zeros. So this p of x here can basically be thought of as y. Okay, so we're setting y equal to 0. We're basically setting this whole thing equal to 0. All right, and we know that any number multiplied by 0 equals 0. So if I set this whole thing equal to 0, this would work if this part equals 0, or if this part equals 0, or if this part equals 0, or if this part equals 0. So I can set each one of these individually equal to 0 and solve this equation. And then at the end, they want us to plot the zeros or the x-intercepts on the graph, but that'll be later. Now, some of these you can do in your head, but I'll do each one individually. Okay, I'll call this part, I'll label this part number 1, and this part in parentheses number 2, and this part in parentheses number 3, and this part in parentheses number 4. Okay, so I'm going to set each one equal to 0, because if this was 0, anything multiplied by 0 would equal 0, and so on. All right, so for number 1, and again, I know some of you can do this in your head, I'm going to set x plus 2 equal to 0. All right, subtracting 2 from both sides. The 2's cancel. Bring down the x, and 0 minus 2 is negative 2. All right, it's that simple. For part 2, 2x plus 7 equals 0. Okay, subtracting 7 from both sides. The 7's cancel. Bring down the 2x. 0 minus 7 is negative 7. Okay, and dividing both sides by 2, we see that x is negative 7 halves, but we're going to be plotting this on the graph, so it might be easier if you use the decimal. If you do negative 7 divided by 2, that's going to be negative 3.5 or 3.5. All right, so we have 2 zeros now. For part 3, x minus 1 equals 0. Okay, adding 1 to both sides. 1 minus 1 cancels. Bring down your x, and 0 plus 1 equals 1. Okay, finally, part 4. X minus 3 equals 0. And if I add 3 to both sides, 3 minus 3 cancels, and x equals 0 plus 3, which is just 3. Okay, so these 4 numbers are my zeros: negative 2, positive 3, negative 3.5, and positive 1. Okay, so we're going to plot those on the graph real quick, just plot the points. So real quick, here is the x-axis. Okay, the line that's on the x-axis is basically y equals 0. All right, that line on the x-axis is y equals 0. So that's why the zeros go on the x-axis. Remember, we set the equation y equal to 0. All right, anyhow, it just says click to add points. Let me rewrite the zeros again. Okay, these were the values we got before. So I'll start with negative 3.5 on the x-axis. Okay, go to your x-axis. Here's negative 3. Here's negative 3.5. Just click on it and it makes a dot. Next up is negative 2, right there. Next up is positive 1, right there. And next up is positive 3. So that's it. Just plot the 4 points or however many zeros you have on the x-axis, and that's it. All right, it looks like these are all the same. I'll do one more. Okay, again, they want us to find the zeros of the polynomial. So this is basically y equals, okay, and I'm going to set this whole thing equal to 0. Now, if this whole thing equals 0, any one of these binomials in parentheses can equal 0. Okay, if this were 0, then these can be anything, and times 0 would give us 0. So I'll label this number 1, number 2, number 3, and number 4. Okay, there's not always going to be 4 zeros, not necessarily. So number 1, 2x minus 1 equals 0. Okay, adding 1 to both sides. The 1's cancel. Bring down your 2x, and 0 plus 1 equals 1. Dividing both sides by 2, x equals 1/2. If you like, you can make it a decimal and say 0.5, same thing, because again, we're going to be plotting these on the graph. All right, for part 2, x plus 3 equals 0. Subtracting 3 from both sides. The 3's cancel. And 0 minus 3 is negative 3. Some of these you can do in your head. I'm just writing them out to show you. Okay, if x plus 1 equals 0, subtracting 1 from both sides, 1 minus 1 is gone, and x equals 0 minus 1, which is negative 1. And finally, part 4, x minus 2 equals 0. Adding 2 to both sides. The 2's cancel, and x equals 0 plus 2. 0 plus 2 is just 2. All right, do you have to do all this? No, you can do some of these in your head. I know if I plug in negative 3 right here, I'll get negative 3 plus 3 equals 0. Positive 2 right here, 2 minus 2 equals 0. All right, so you don't have to write it out every time. So you just scroll down to the graph, you find your x-axis, it's the horizontal axis, and plot the points. We have negative 3, x equals negative 1, x equals 0.5 or 1/2. Okay, this is 0, this is 1, this is 1/2 right there in between. And finally, positive 2. Okay, so we got our 4 points. They are all on the x-axis. And just real quick, if you have something like this, you set this 3x equal to 0. Okay, 3x equals 0. And of course, when you divide both sides by 3, and the 3's cancel, 0 divided by 3 is still 0. So in that case, x would still be 0. Okay, it says a polynomial p is graphed. What could be the equation of p? So on this problem, we have to work backwards. Okay, and we're going to get the zeros from the graph. Remember, when you find the zeros, you basically set y equal to 0. Well, this x-axis here is the graph, of y equals 0. So in order to find the zeros, all we have to do is go on the x-axis and see where the graph crosses the x-axis. So for the zeros right here, we have -3. And then right here we have -1. And then right here we have 1/2. It's between 0 and 1. So I'm going to write 1/2. Now, in order to find the equation for these zeros, all you have to do is change the sign on each one. Okay, so each one is going to start with an x. And you just change the plus minus sign. So instead of -3, you put +3. Instead of -1, you put +1. Instead of +1/2, you put -1/2. Okay, and that's basically it. The only small problem is they don't have fractions in their answers. Okay, if you scroll down, you can see none of their answers have fractions in them. So what you do for the x minus 1/2 is basically multiply by the denominator. Okay, so if you take a 2, the denominator here is 2. If you take a 2 and distribute it, you get 2 times x, and then 2 times -1/2 is just -1. So instead of this right here, we're going to use this binomial. Okay, it works out to be the same because if you set this equal to 0, you will still get 1/2. So when you get a fraction, multiply that binomial by the denominator and distribute it and make a new binomial. Anyhow, this is the answer. X plus 3, x plus 1, and 2x minus 1. And that looks to be answer D. X plus 3, x plus 1, and 2x minus 1. All right, last one. A polynomial has zeros at 5, -1, and -1/4. What could be the equation of P? Okay, so this is just like the last one, except there is no graph. So just like last time, you want to change the sign on each one. Okay, we're going to have 3 binomials, one for each 0. And just change the plus minus sign on each one. So here we have +5, and you make it -5. Here we have -1, you make it +1. Here we have -1/4, you make it +1/4. Okay? And the way to get rid of the fraction here is to multiply this binomial by the denominator. Okay, so we take the 4 and we distribute that to both terms. So we have 4 times x, and 4 times +1/4 is +1. So this is the new binomial in place of the old one. Okay, and this is your answer right here. So we have x minus 5, x plus 1, and 4x plus 1. Right here, x minus 5, x plus 1, 4x plus 1.